Good morning from Professor Simon. Over the last year I've made nearly 100 films, and one or two of them have had copyright claims made against them by YouTube and the owners of the copyright. What YouTube lets you do is use other people's images and films as long as you edit them in a significantly different way and make new content. That's part of the YouTube agreement. But what's annoying is if you've used a shot that somebody claims is theirs and doesn't approve you reusing it, maybe it's only like 2 seconds long out of a 20-minute film. The film is blocked in certain countries, it's demonetized from you, and the person with the 2-second shot gets to keep all the money from any views that people look at. So I've come up with this idea of putting the contested shots in a split screen. So on one side is the contested shot and the other is some other random shots which kind of could be relevant. Let me know what you think, but it means that I can re-upload the films for you to watch. They won't be blocked and maybe you'll enjoy them. This first one is a film about the cosmic microwave background. It's a brilliant subject. That's the light that's left over from the Big Bang, which in recent years we've been able to see and map the very early universe. It included some shots from the film library Pathé, and it illustrated the point of a radio telescope in Cambridge working that I wanted to use, and they blocked it. So I've put it in a split screen. If you hate it, let me know in the comments, but if you enjoy it, also let me know. So, cosmic microwave background. What is the connection between the phone company, Telstar, and the Big Bang? It became one of our greatest discoveries in science. Proved our universe started in an extremely hot and violent way. Revealed you and I are made of elements 13.8 billion years old. Gave us the first baby picture of the cosmos, and won, to telephone engineers, the Nobel Prize for Physics. In 1965, Arno Penzias and Robert Wilson were asked to investigate an annoying buzz heard on all satellite telephone calls. The Bell Telephone Company had an oddly shaped horn radio antenna in Humdel, New York. They found the buzz, but noticed it seemed to be coming from everywhere, not just on the satellite circuit. One possible source of the noise was the pigeons using the antenna as a nest. They relocated the birds, but there was still a persistent buzz. They turned the antenna towards New York City and the airport, looking for man-made interference, but found nothing new. They had a bright idea. The buzz was a signal from the sun, but it was still there after dark. The astrophysics department at Princeton University heard about the phone company's problem and realized their buzz was just what they were looking for. Physicist Robert Dicke had a theory on the origin of the universe, but he had no antenna to check his ideas. Bell Labs had an antenna with a buzz and no idea where it was coming from. In Cambridge, England, a fierce debate was raging. On one hand, the origin of the universe was thought to have occurred in a violent explosion. The opposing theory was the universe had no creation moment and existed in a steady state. The proponent of the steady state theory was Fred Hoyle. He made his case for his pet idea on a BBC radio broadcast.
The BBC presents The Nature of the Universe,
where he disparagingly called his rival's explosion theory just a big bang.
Perhaps like me, you'll grow up with the notion that the whole of the matter in the universe was created in one big bang at a particular time in the remote past. What I'm now going to tell you is that this is wrong.
The term Big Bang caught the public's imagination and has become the name of the rapidly expanding moment at the beginning of the universe ever since. I was fortunate to visit the site of Cambridge University radio telescopes. Fascinating structures, but even more interesting to realize that from here, the answer to whether the universe was born in a Big Bang or was in a state of continuous creation could be measured. Ryle built the 1 Mile telescope on a track of a disused railway line near Cambridge. It consists of 3 dishes. They work together to gather faint radio signals from space.
Professor Sir Martin Ryle chooses the exact spot from which he will make his soundings. It takes a massive piece of intricate ironmongery to dig, in space, a radio telescope. The 3 giant dish aerials, one can be moved along a railway track, become one big radio receiver, about a mile across when they're all scanning the same area of sky.
Now, can you explain exactly what you've been doing?
According to the theory of continuous creation, the density of galaxies would be the same in the neighborhood of the Earth here, right out to the edges of the observable universe. And one way in which one could test the 2 theories is to make a measurement of the variation of the density of galaxies with distance from us.
What he discovered was as you looked further away, so back in time, galaxies were clustered closer together. Nearer to home, and hence more recently, the universe was slightly more spread out. This proved that we live in an expanding universe. And by running the cosmic clock backwards, you can imagine a time when the universe was tiny and everything was closer together. It was possible to give the universe a birthday. Maybe not a day and a month, but you would need 13.8 billion candles on the universe's birthday cake. The theory predicted a moment when the hot energy turned into atoms we see today. This gave off a tremendous flash of photons that we perceive as light. Over 13.8 billion years, the light energy has aged, slowed down and stretched into a lower electromagnetic frequency. Today we can pick up this as microwaves, in the same bandwidth as early communication satellites used. Exactly as Robert Dicke from Princeton had predicted, and precisely what Penzias and Wilson had heard on the Bell phone antenna. We call this noise the Cosmic Microwave Background, or CMB. But there was a problem. The CMB should form a baby picture of our universe. Dense areas would become galaxies, and thinner parts would expand to be the space between the stars. The early universe was very close to being spherically symmetric, making it hard to see different areas of density. Astronomers looked and found nothing.
The astonishing thing is that the harder we looked, the more mysterious the universe became, because all we saw was a blank sheet of paper. Nothing was written on it at all. And we went down to a part in 1,000, it was a blank sheet. We went down to a part in 10,000, it was a blank sheet. It was at this point that my colleagues at Caltech started telling me that I was proving we weren't here.
If there were no lumps, then there could be no Earth and no us. For 30 years, no one was able to see any details in the ancient light left over from the Big Bang. It took a clever, persistent, and brave astronomer working in one of the most inhospitable places on Earth, high up in the thin air of the Chilean desert, to see the faintest variation in the signal. Tony Reedhead from Caltech built this telescope that looks like a collection of tin cans called the Cosmic Background Imager. Tony's telescope saw tiny, detailed variations.
3, 2, 1, main engine start, and liftoff of the Delta II rocket with the MAP spacecraft.
Observing from Earth was hard. To see the bigger picture, we would need an instrument thousands of times more sensitive. In 1989, the Kobe satellite was launched to gather a bigger picture of the early universe. The ancient light was now so faint, the satellite had to go to a special, quiet and dark place in our solar system. It was sent to a Lagrange point, named after the French mathematician Joseph Louis Lagrange. This spot in space is 900 kilometers from Earth, and the satellite was given an inclination of 99 degrees to shield it from the sun. It still took 6 months to survey the visible universe. Eventually, Kobe sent back the first baby picture. 13.8 billion years old. Since Kobe, we have improved the resolution of this picture with a WMAP and Cobra satellite surveys. All we have to do is join the dots to work out how we got from the baby picture to the vast adult cosmos we have today. The truth is out there.